Well, hey guys, here is your video for today. We're going to talk about fractional exponents. So everything we do today is going to be written in one of two forms. It will either be written in exponential form, where I will write the base with an exponent, or it will be written in radical form, where it will be written as the base with a radical, a square root or a cube root or some form of radical. So we'll go both ways, and then we'll simplify as best we can after that. But the thing that you need to understand is that if you have the nth root of something, the square root, the cube root, the fourth, whatever, if you have a root of something to a power, so x to the a, the nth root of x to the a, then it can be written with a fractional exponent as that base, the x, to the a over n. And so I can create a fraction using my exponent and my root. The root always goes in the bottom of the fraction, just like if you have a flower or a tree or grass or something that you've planted out in rose bush, whatever, the roots go underneath the ground. They go on the bottom. We don't usually see the roots up top. So the root goes on the bottom. So whatever is out here outside the radical is the root. It goes on the bottom, and then the exponent goes on the top. So we're going to start by just converting between radical exponent form and rational exponent form so that you can see both and how that they go together, so we can practice this, and then we will move into some simplification problems involving this. So number one here is written as a radical, so it looks like this part, and I want to rewrite it so that it has a rational or fractional exponent. So the base is x, and then the fraction becomes the exponent inside over the root outside, so it's x to the 7 over 4. Number two here is the fourth root of x. Well, that's like saying this x has an exponent of 1 on it. So if I want to write it in fractional exponent form or rational exponent form, my base is x. And then to get my exponent, it is the exponent inside over the root outside. So it becomes x to the 1/4 power. So number 3 and number 4, though, are written already with a rational exponent. I want to rewrite them as a radical. So I'm going to turn that rational exponent into a radical. Well, the base is an x, so I know I'm going to have a radical with an x inside. It's just, where do these two numbers go? The top number goes inside with the base. The bottom number goes outside and becomes your root. Done. So number 4 here is 100 to the 1/2 power. So I'm going to have a radical with 100 underneath it. The 1 is my exponent. The 2 becomes what goes with my radical. Well, you don't really have to put that because the 2 just means it's the square root. So we'll simplify this. 100 to the first power is just 100. So this is really the same thing as saying, what's the square root of 100? Well, the square root of 100 is 10. So a square root can be written as anything to the 1/2 power because of this. The 1 would be inside and the 2 is what's outside. So 1/2 power always means a square root. And then you can just take the square root of whatever it is. But they are the same thing. So that's how we simplify and go between radical form and rational exponent form. So there's the two. So now let's practice doing some simplification. So if you look at number 6, you have -8 to the 1/3 power. Well, the first thing we're going to do is we're going to rewrite this so that it looks like a radical. So the -8 is in parentheses, which means the whole thing is to the 1/3 power. So if I write this as a radical, I know that I have my -8 inside the radical. The 1 is my exponent, and then the 3 is my root. So I want the cube root of -8. Well, you cannot take an even root of a negative number because the square root of a negative, if you'll remember, is an imaginary number because that's the only way to make it happen. That's true no matter what the root is if it's even. So a square root, a fourth root, a sixth root, anything that's even you can't do if it's a negative. But odd roots, a cube root, a fifth root, a seventh root, you can go on and on. Those can all happen because you can get a negative number when you take an odd root. That does happen. And so if I want the cube root of -8 or just the cube root of 8, well, to get 8, I'd have to do 2 times 2 times 2. So to get the -8, it'd have to be -2. So the cube root of -8 is -2. Now you can also do this another way. by grabbing your calculator and just typing in what you were given. So we know we have -8 to the 1/3 power. It will give you the solution, and that's fabulous. You do, however, need to understand how to go between the rational exponent form and the radical form, because you don't always have just a number. Sometimes you've got a variable going on and you have to be able to simplify into the other form based on what you're being asked for. But this gives us a number, so I can use my calculator. So I can grab my calculator here, and I can type in what I was given, which was -8 to the 1/3. So in parentheses, I can do -8. You need to make sure you put it in parentheses, otherwise the calculator does not understand that the negative belongs to it, goes with the number. That when you take the root, you actually want the negative to go with it. If you don't put it in parentheses, the calculator will think that the negative is not with the number, and sometimes it messes things up. So we're going to do -8 to the 1/3 power. Well, to get the exponent, you hit your little arrow key here, so you're to the power of button. And I want to make that a fraction. Well, these calculators are so awesome. If you do alpha, y equals, and then enter, you get an option. You can make a fraction, and you can do 1/3. And so now I have -8 to the 1/3 power, and if I hit enter, it's going to tell me that it's -2. So you can simplify using your calculator. But please, I need you to understand, it is very important that you be able to go between rational exponent form and radical form, because you never know how the questions will be asked. So let's look at number 7, which is 121 to the -1/2 power. And yes, you can simplify. You can completely simplify this using your calculator. But this answer to this is a fraction. So your calculator was probably going to give you a repeating decimal as an answer. That's not what I want to see. I want to see the fraction that goes with it. So let's talk about what this really looks like when I write it. Well, remember, negative means that I have to rewrite this. I've got to move it. So I have to rewrite this as 1/121 to the 1/2 power. And we talked about just a second ago on the page before this that anything to the 1/2 power is the same as a square root. So this is really the same as saying 1 over the square root of 121. And you can use your calculator for this, because the square root of 121, if you don't have it memorized, is 11. So you end up with 1 over 11. If you try to put that in your calculator, 1 over 11 becomes the decimal point 111 repeating, and it goes on forever. Well, don't write that down. That doesn't tell me anything. I need the fraction 1 over 11. That has much more meaning to me. So that's your answer, but that's how we got to it. So now look at number 8. Number 8 is a negative number again. It's not in parentheses like the 6, so the negative does not go with the number, or it's not part of the root, but that's okay. It doesn't have to be in parentheses. Here's what you need to understand. Let's rewrite this as a radical really quick. If I rewrite this as a radical, I get a -16 in here with an exponent of 1, and then it's a 4th root. Well, if you'll remember what I talked about here on number 6, a negative number, if it has an odd root, is cool. That's all good because we can find that. But a negative number with an even root like this one, it's going to have an imaginary solution. And so when you simplify this, it's going to have that I part to it because it's going to be imaginary. So you can, if you want, find out what the 4th root of 16 is. So what number times itself 4 times gives you 16. And then you'll have to attach the I. Well, the 4th root of 16 happens to be 2, because if you do 2 times 2 times 2 times 2, it gives you 16. But because it's -16, then the answer to this is 2i. It becomes imaginary because it is at a positive root. The negative root was cool because that's possible. With a positive root, it is not possible, so the negative number gives you an imaginary value. So now number 9, let's rewrite it as a radical. So you have your radical with an 8. Squared goes inside, as the top number goes in, and then the 3 is the root. So we'll simplify here. I'm going to end up with the cube root of 64. And I can do that on my calculator. And here's how you do it on your calculator. If you want to find the cube root on your calculator, you have to press this button that says Math. And you'll see right here that option number 4 is a cube root. And so if you hit number 4, it'll bring up the cube root, and you can just type in 64. And you see that the cube root of 64 is 4. Because if you do 4 times 4 times 4, it makes 64. And so that's how you do a cube root on your calculator. And so this becomes 4. You also could have done, like I showed you, 8 to the power of 2/3, just like we did with number 6. and it should give you the same answer, but I want to also be able for you to rewrite it in radical form so you can see. So look at number 10 here. And I have 4x squared to the 3/2 power. So before I do anything with this, this is one I cannot do on my calculator because I have a variable. We don't know what x is. You can't just plug it in. But I can rewrite it in radical form. So my base is 4x squared. So under my radical is going to go 4x squared. And my exponent on that is going to be a 3. So I have 4x squared to the 3rd. And that is all the square root. Well, you don't have to put the 2 because the square root is understood if it's not there, but you can put the 2 if it makes you feel better. So I've got to simplify what's inside here first. So I have the square root of, we'll have to do 4 to the 3rd power, which we just talked about with this last problem, is 64. And then remember I have to distribute my exponent, so 2 times 3 is 6, so I have x to the 6th power. And that's also the square root. So let's take square roots. Well, the square root of 64, you should know, is 8. And then x to the 6th. We talked about this yesterday just a little bit, so let's review it again. To get x to the 6th, to get the exponent, to take the square root of that, it's not what number times itself. It's going to be a number plus itself, because when you are multiplying things with exponents, you add the two exponents. So the number that you add to itself to get 6 is 3, because 3 plus 3 is 6, so it becomes 8x to the 3rd. So now number 11. There are a couple of ways to approach number 11. For number 11, you can do 27 squared and then take the cube root of that. Your calculator will do all of that for you. Or you can take the cube root of 27 and then square the final answer. I don't care which way you do it, but I prefer the second one because the cube root of 27 is something I know already. I know that in my head. If you don't know that in your head, it's okay. You can take the cube root of 27 on your calculator, just like we did with this. So you'll do math. You'll choose option number 4, and you'll type in your 27 for your cube root, and you should see that the cube root of 27 is 3. So I've now simplified this down. The cube root of 27 is 3, so this becomes 3 squared, and 3 squared is 9. So that's the solution to that. You can also, just like we talked about, you can do your cube root, and you can do the cube root of 27 to the 2nd power, and you can hit enter, and you're going to see it gives you the same answer. It's 9. Your calculator will do a lot for you if you'll just trust it and actually use it. It's there for a reason. Use it. It will help you out. So let's do a couple more and then we'll be done, and we'll have time for your practice. So number 12 here, we did one similar to this a minute ago with 121 to the negative 1/2 power. We're going to do one more so that you can see. Now your calculator will do this for you, but I want you to see. We're going to rewrite this because it's negative. I'm going to rewrite it as 1 over 125 to the positive 2/3 power. So I made my exponent positive. So if I rewrite that in radical form, I get 1 over 125 squared and the cube root of that. Now, just like with this problem that we had just a second ago with the 27, you have two choices. You can do the cube root of 125 and then square that number, or you can do 125 squared and then take the cube root of that number. The first one is easier because if you do the cube root of 125, you are working with smaller numbers. If you do the second option and you do 125 squared first, you're going to have a really big number to work with. I like my numbers to be smaller. So I'm going to grab my calculator and I'm going to find the cube root of 125. I'm going to hit the right button first. So you have math number 4, and I want the cube root of 125, which is 5. So my answer here becomes 1 over 5 squared, because the cube root of 125 is 5, and then I still have to square that. So this answer becomes 1 over 25. Now if you do that on your calculator, if you just start from here and you do the 125 to the power of, and then you do your fraction, and you do negative 2 over 3, and you hit enter, it is going to give you a decimal 0.04, and that decimal is okay. It has a definite end. It does not repeat. It's short and easy and nice to look at. You don't have to round or anything. That's okay, but I'm not going to want to see decimals as answers. I'm either going to want to see a number with a rational exponent, I'm going to want to see a radical, or I'm going to want to see a fraction as an answer. So if you do this on your calculator, make sure that you then go to Math, choose option 1 to convert that to a fraction, and hit enter so that it will tell you that as a fraction it's 1/25. Because I'm going to want the fraction answer, not the decimal answer. Not that they're not the same thing, but I want to know that you understand that that became a fraction. And then that way, if you get a decimal and it's a repeating decimal, or it's one of those really long decimals with lots of numbers, and I don't want all of that information. Fractions more accurate, that's what I want to see. So number 13 here, it's a division problem, but before I do this division problem, I've got to simplify the denominator so that I have exponents that I'm going to deal with, so that when I try to use my rules that we have learned and talked about the last 2 days, everything has an exponent. This right now is written as a radical, so I'm going to leave the numerator the same. So I'm going to have r squared t cubed over. Now I'm going to write this with a rational exponent, so it becomes t to the 3 over 4. So I've taken my thing and I've made it a rational exponent. Now if you'll remember our division rules, when you divide bases, like bases, you have to subtract the 2 exponents. So that's what's going to happen. Now the r here has nothing to divide with, so you're going to keep your r squared. But I'm going to have to subtract 3 minus 3/4, and so your calculator will do that. If you do 3 minus, and you do your fraction, 3 over 4. If you do 3 minus 3/4, it gives you that the fraction is 9/4, and so your t becomes t to the 9/4 power, because I subtracted these 2. That's what it became. If you want to get really serious, you can do 3 minus 3/4, find a common denominator, then subtract, and then write it down. Your calculator takes care of all of that for you, so please use it. That's why it's there. So last question we're going to talk about is number 19. Number 19 asked you to evaluate, which means we're going to plug in a number and get a definite answer for this problem. So I have f of x is equal to x to the 2/3 plus x to the -3, and I want f to evaluate for f of -8. Which means that x is -8. So I'm going to take my f of -8 and I'm going to plug in. I'm going to have -8 to the 2/3 power plus -8 to the -3 power. And we're going to simplify this. So now your calculator will take care of all of this. It doesn't ask you to write it in a specific form. It doesn't say put this in rational form, rational exponent form, or radical form. It just, I want you to evaluate. So I want a solution. So calculator work is totally fine here. So I'm going to take my calculator and I'm going to do my -8 to the power of, and then I have to do 2/3. So I'm going to do my fraction. So I have 2/3. And then I have to arrow to get out of the fraction, and then arrow again to get out of the exponent. And I have to add to that -8 to the power of -3. And my calculator is going to do that for me, and it's going to give me this decimal. I don't want you to write this decimal. That is not accurate enough. It doesn't tell me a whole lot of anything. It's just a bunch of numbers you're going to have to round. So I want to convert this to a fraction. So we're going to hit Math. And number 1 will convert it to a fraction. So this takes my answer, turns it into a fraction. If I hit enter, gives me this really ugly fraction, but that is the correct answer. So the answer becomes 2047 over 512, which still doesn't tell me a whole lot more than that decimal that you just saw written down, but it comes out to be about 4, because if you look at that value that we had on here, it's 3.999998. It rounds up to about 4, so that's an acceptable answer, but that's what this evaluates out to equal. So that's how you're going to do rational exponents. You have practice to do over that. Tomorrow when I come back, I'm going to check your practice that you did on Wednesday night, so the stuff over the expressions and equations, and then I'm going to also check this homework over this, so you will have 2 assignments you need to have ready for me when you come to class tomorrow. I will see you guys then.